Hi everyone, this is lesson 221 on dilations. Now, before this lesson, and I think probably even before this course, you were introduced to transformations, rigid transformations. And that's, if you don't remember your rigid transformations, those would be reflection, rotation, translation. Those are our different transformations. So dilation is another type of transformation, but it's not a rigid one. So rigid one means really your shape doesn't change. So in a dilation, the shapes could be enlarged, or it actually can shrink as well. So we're going to be looking at enlarging some shapes today. Usually we enlarge, but it can be shrunken down as well. And then the other term we need to be familiar with is similar, right? Similar shapes. So two shapes are considered similar if they have the same shape, right? So when you see two things that look alike, we say, oh, those are similar, right? So in this case, we're going to look at that a little bit more closely in how it relates to dilation. All right, so we're just going to jump into some examples, and you might want to, if you are copying this down, I would recommend, if you have graph paper, this might make it a little bit a lot easier for you. This is kind of the main reason why we recommend you have graph paper. Or if you don't have a notebook of graph paper, maybe you have a sheet somewhere that you could just do this on, or even if you could do it online as well. Let's see. So here we have a quadrilateral. This is quadrilateral ABC. So you can see the points A, B, C, D, right? A, B, C, D. All right, so this is the shape we have. What we're going to do is we're going to dilate this shape. We're going to enlarge it. All right, so the first one is going to be by a scale factor of 2. And we're going to rename it. We're going to, instead of using the letters A, B, C, D, we're going to rename it with these apostrophes, which we call primes. So this will be A prime, B prime, C prime, D prime. Instead of us using different letters, we like to use the same letter, but put an extra marking so that we know it belonged to the original. And then we'll do this with a scale factor of 3 as well, or zoom factor of 300. And then this is what we call A double prime, B double prime, C double prime, and D double prime. All right, so those are the two examples we're going to do on this graph. You should notice there's a point of dilation. Right? So when we make things larger, we need to know what's the point that it's growing from. So in this case, it's actually growing from the center. We're going to look at an example next after this graph where the point of dilation is actually outside of the shape. All right, so let's see what happens, and let me show you kind of how to generate our scale factors here. So the main thing that we're going to do is from the point of dilation, we always start from the point of dilation, and we're going to figure out, how do I get to point A? Well, for those of you that are familiar with slope, what I like to use is just a rise and a run. So I'm going to go up 1, 2, and I'm going to go over 3. So up 2 over 3. So if I do that slope once, that would be a dilation of 1, a scale factor of 1. But I want a scale factor of 2. So that means I'm going to do that slope twice. Up 2 over 3, up 2 over 3. And you'll notice the same slope. There's the same slope. Right? You can imagine there's like a line here. Right? And it goes through this point, which we're going to call A prime. So let me identify that. So I'm going to go up 2 over 3, up 2 over 3. Right? Kind of looks like a staircase. All right, and all we're going to do is focus on the points. Don't even worry about the lines. We're focused on the points. And so I'm going to do the same thing with point B. So from the point of dilation, how do I get to point B? Well, if I go up to the left one, okay, so I'm going to do that twice as a scale factor of 2. Up 2 to the left 1, up 2 to the left 1. All right, so then I'm looking at my point B prime being over here. All right, so let's do that. So I'm going to go up 2 over 1, up 2 over 1. And let's put a point here, and let's call this B prime. And we're going to repeat this process for all the points. So try to do this. I'm going to try to do it a little bit faster. So for point of dilation to C, we're going to go down 2 to the left 2, down 2 to the left 2. Right. So that means we're going to be here. This is going to be my C prime. And then down 2 over 2, down 2 over 2. And then the last one is D, which we're going to go down 2 to the right 1, down 2 to the right 1. All right, so that gives us our D prime. All right, so once you have those 4 points, the next part should be easy. Just connect the dots. All right, so instead of going from A to B, we're going to go from A prime to B prime. And from C to D, we should have a line. So C prime to D prime. And then from A to D, and then from B to C. All right, so you should have a shape that looks like that. You'll notice it looks like the same shape as the original. It just happens to be larger. And so this is what we say is a scale factor of 2. Or maybe you might think of this as a zoom factor of 200. Like when you zoom into a picture or maybe your Google Doc where you want to zoom in, that's how much bigger it would get. All right, so let's do the same thing for a scale factor of 3, which is a zoom factor of 300. All right, so I'll start this, and then if you would like to finish it, I'll give you some time to do that. Well, I guess you would just pause so if you want to try to do it. So I'm going to, let's see how far I could get on here. All right, so I'm going to continue the same slope, up 2 over 3, up 2 over 3, up 2 over 3. I'm going to put this up 2 over 3. So that means this is my new A double prime. And then let's see, up 2 over 1. This is going to be my B double prime. And then C prime, I'm going to go down 2 to the left 2. This is my C double prime. And then D would be down 2 over 1. This is my D double prime. All right. So if I connect those, let's see if it's, oops, kind of doesn't, it almost gets too straight. All right. So there we have our 2 dilations. The one in green, well, the original one is in black. The original one is our dilation of 1, the original. And then we have our dilation of 2. And then we followed it up with a dilation of 3. All right, you should notice all these lines are parallel. And in the bottom as well, all these are parallel. And then even the side ones, you'll notice all these are parallel. And then the ones on the left, these are all parallel as well. All right, so there you should notice similar connections. Even all these angles should be the same as well. All right, so that's kind of the basics of what we're doing. Maybe you want to rewatch this if it's a little bit confusing. We're going to go on to the next diagram. So the next one has has a point of dilation that's not in the center. All right, in this case, the point of dilation is actually outside. This is point D. Right, so point of dilation is outside. And the triangle we have is triangle FGH. And we want a scale factor of 3. Now I've already started this with a scale factor of 2. And then I'll show you kind of how I'm getting those points. And then we'll see how far we get with scale factor of 3. All right, so definitely make sure if you're plotting this, you're graphing this on your paper, try to make sure you're getting the accurate points that we have here. So make sure you're graphing this correctly. If you're not doing this on graph paper, and chances are your graph's not gonna come out very good on line paper. So, and if you do have it on graph paper, double check, triple check that you're putting these original points in the right place. Because people always you might do everything right, but your original triangle is not in the right place. So maybe make sure to double check that. All right, so the way we do this, just like with the other example, we start with the point of dilation. Right, you always want to start here. All right, so from point D, I always ask myself, well, how do I get to each of the vertices of that triangle? So from D, how do I get to F? Well, this is where the slope comes in. So D, I'm going to go up 2 to the right 2. Up 2 to the right 2. All right, you'll notice the same pattern. And I could keep doing this. I could do this as many times as I need to, depending on what my scale factor is. Now, when I do it once, that's a scale factor of 1. When I do it twice, that's a scale factor of 2. And so if I want another scale factor of 3, then I would do it one more time. So let me put that point in. So this one we'll call, since it was a scale factor of 2, let's be consistent, and I'm going to label this one F double prime. And I'm trying to use different colors here so you could tell the difference. From point H, I'm going to go up from D, start here, I'm going to go up 3, and then I'm going to go over 3, 4, 5, 6, 7, 8, 9. So up 3 over 9. So I'm going to go, oops, let me erase this point. I'm going to go up 3 over 9. So up 3 over 9, up 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so my other point, oops, 1, 2, 3 over 9, 1, 2, 3 over 9, up 2 over 2, up 2 over 2, 2 over 2. Oh man, what am I doing wrong? This is 2, up 3 over 9, up 3. Oh, I know what I'm doing. Up 3, 4, 5, 6, 7, 8, 9. So 3, 4, 5, 6, 7, 8, 9. I think it's right here. Oops, wrong color. So that was the first one. That's my green one. And then I'm going to do it one more time. And so I'm going to go up 3 over 9. 3, 6, 9. All right. And so that's about this one. This is 25, 26, 20, was that 28? All right. So let's do up 3 over, I think it was this one. All right, so this would be my H double prime. So me draw in my dilation of 2. This is confusing me. All right, so dilation of 2 is there. This is f. Oops. This is f prime. This is h prime, and this is g prime. All right, we're trying to do scale factor of 3. All right, so that's the one in blue, and then g, we're going to go from d to g. So that's straight across. That's easy. 3, 6, 9, 10. And then I'm going to do 3, 6, 9, 10. All right, so there's my scale factor of 2. And then I'm going to do it one more time. 3, 6, 9, 10. All right, so that's almost at the end. So that should be here. So this is going to be our G double prime. All right, so if I connect those, let me make this a little bit thicker. So I'm going to connect that one, H, and then that one. All right, so you should end up with, you'll notice, in mine I have 3 triangles. Technically we only needed 2, the larger one. That, yeah, the blue one's probably the one that is the one that we needed. So this is F double prime, G double prime, H double prime. Right? Scale factor of 3. All right, so those are 2 examples of dilations. I showed you, just to remind you of the previous one, there's that one where the center was the point of dilation and everything looks like it's growing from the center. And then this is an example where everything's growing from the side. So you should notice all these are lined up. I could actually draw a line. Oops. I actually could draw a line that goes through all the F's, all the H's, and all the G's. Right. So they're growing based on those lines. All right. And the last part is kind of back to the idea of similar triangles. So are these triangles similar? And when we ask a question like this, we're asking, really, are they the same shape? Do you notice if there's any type of dilation? Right? So when we dilate a shape, it gets bigger or smaller, but the shape still looks the same. Right? A miniature version or enlarged version, it's kind of like Super Mario Brothers. When Super Mario gets the mushroom, he just becomes an enlarged version of himself. He gets dilated. All right, so are these triangles similar? They may or may not look like it to you. When I look at it, they kind of don't look the same. But sometimes right away when we see shapes that don't look the same size, then we say, oh no, those are different. But in this case, similar means all they have to be is the same shape. They don't have to be the same size. All right, so let's look closely at the measurements. All right, so in this case, I'm looking at the measurements. I have 5, 8, 9. Well, there's no 5, 8, and 9 on these triangles, so clearly they're not congruent triangles. So then I look to see, well, how are the measurements related? Well, I notice 5 and 10. Well, if I multiply 5 times 2, that gives me 10. And if I multiply 8 times 2, that gives me 16. And 9 times 2, that gives me 18. So it looks like everything happens to be, if I multiply everything by 2, it gives me all these measurements, which then tells me that this larger one is a dilation. That's 2 times, or it's a scale factor of 2. or we could even say this is 200%. All right, so then we're thinking these two triangles must be similar. And so, and we'll go into other ways of proving that a little bit later. But for the most part, if we know they're similar, let's look at, do we know how to name these triangles in a statement showing that they're similar? So here's 4 statements. Which ones are written correctly? Well, they all have the same letters. They all have D-O-G, C-A-T, right? D-O-G, C-A-T. So they all have the same letters, but you'll notice they're kind of in different order. Right? So the order of these letters matters. It doesn't matter for the first triangle you've mentioned, but the second triangle has to match up with corresponding angles of the first triangle. And so usually the way I do this is, and this might make sense if you think of it in terms of, I guess, the measurements. I'm going to use the measurements in this case. So I'm going to start with the smallest side, from G to O, and then the next side from O to D. Right? I chose these two because these are the two smaller sides. So if I'm looking at the bigger triangle, well, which is the smallest side in the bigger triangle? Well, 10. And which is the next largest? Well, that's 16. All right, so then those match up. So that means to me that G and A correspond to each other, and O and T correspond to each other, and D and C must correspond to each other. So when we use these letters from the original triangle, the left triangle, we need to match them up with the letters from the right triangle. All right, so I'm looking at D-O-G, D-O-G. So in this case, does that match with C-A-T? Well, D is supposed to match up with C, so that's good. D and C match up. Does O and A match up? Well, O and T are supposed to match up. So then this is not good. Right? So then I would not, this is not a good one. All right. And then, so we go through each of these. So I'm looking for the ones that have a D and a C matched up. So I'm going to look through these, and I see, let me see if I could just mark these. So D and C match up there. Oops. D and C, D and C, D and C. All right, all those are good. So let me match up G and A. G and A. So does G and A, these are not in the right place. So, and then G and A, those are good. G and A, those are good. Well, if 2 out of the 3 are there, then that means O and T, O and T, O and T. All right, so it looks like we found the ones that worked. All right, so those are correct, written correctly. The other 2 were not. All right, so it does matter the order that you use. The corresponding angles must match up. All right, so that's it on this lesson. It's a little bit longer than I expected, but that's it for now.